Hi class, this is section R.8 on nth roots and rational exponents. Part 2, adding, subtracting, and multiplying. Okay, so just to review, from the last video, we saw that one way to simplify radicals is that if you're multiplying, we can separate this into two separate radicals. So it works for multiplication and also division. Okay, in this section, or in this video, we're going to start on the right-hand side of the equation and write our expression in terms of one radical, and then try to split it up differently. And also, when we get into adding and subtracting radicals, remember that we can only add and subtract like radicals, which means you have the same index, so 3 in this case, and the same radicand, which is the number under the radical, so 2 in this case. Okay, so adding and subtracting radicals, we need to have like radicals, which you can think of as having like terms, so it works the same way. Okay, we're up to example 3. We want to simplify the expression, and we'll assume all variables are positive. Okay, so you can see that we're multiplying these two radicals together. However, I want to bring them together underneath one radical, and then see if it gets easier to solve. Okay, so I have 5 times 20, so 100. Multiply my x's together, I have x to the 4th, so this works out nicely. This is now a perfect square, so take the square root, we'll get 10x squared. Okay, part B, we're still multiplying, so I have 5 times the square root of 8 times -3 times the square root of 3. So we still want to multiply the coefficients together first, and we'll get -15, and then multiply the radicals together, and we'll get the square root of 24. Okay, this we need to keep going on. 24 is not a perfect square, but it does contain a perfect square as a factor, so we're going to think of 24 as 4 times 6. Break it up into two radicals. Okay, the square root of 4 is 2. And remember, these numbers being multiplied together, so 15 times 2 will give me 30, so -30 times the square root of 6 is our answer. Good. Okay, part C. We now have two binomials, so we need to FOIL. Rad 7 times rad 7 is going to be 7, so you could just write that down. If you weren't sure of that, so rad 7 times rad 7, multiply the 7's together to get, 49. And the square root of 49 brings us back to 7. Okay, good, keep going. So then we'll have +3 times the square root of 7, distribute the -2, -2 times the square root of 7, and then -6 at the end. Okay, you want to add any like terms and like radicals, so we'll add our numbers together, 7 minus 6, and then the radicals, so 3 rad 7 minus 2 rad 7 gives us rad 7. Okay, part D, we are now subtracting radicals. However, we don't have like radicals at the moment. One of them is the square root of 12, and the second one is the square root of 27. Okay, but neither one of these are simplified. So over here on the right, I'm going to simplify 2 times the square root of 12. So let's break 12 up as 4 times 3. Okay, the square root of 4 is 2. So I really have 2 times 2, or 4 rad 3. Okay, now we'll do the same thing for the second guy, 3 rad 27. Let's break up 27 as 9 times 3. So I have 3 times the square root of 9 times the square root of 3. The square root of 9 is 3, so 3 times 3 is 9, and I solve my rad 3. Okay, so we see now we do have like radicals, so let's go ahead and subtract these guys. We'll end up with -5 rad 3. Okay, example 4, I want you to complete these 3 and then turn them in through Canvas. So for the first one, you're multiplying. Part B, you're also multiplying, but you have binomials, so you'll need to FOIL. And part C, add or subtract your radicals. So subtract in this case, but first come up with your like radicals. Okay, good luck. Let me know if you have any questions.